Hello folks, welcome to the Shadow's Edge, and as you can tell from the thumbnail, we're going to be looking at what's inside one of these M12 batteries of the compact ones. So not only are we going to check out what's inside, but we're also going to do a little bit of testing and some troubleshooting tips for when devices say that they're bad. So let's get into it. Can't find out what's inside without taking it apart. And as all tool manufacturers that I've encountered, of course, they use those security bits. This one's a T10. It's trying to protect their investment, I guess. Okay. That's out. Stay. Good. Okay. Now I just gotta get these clips up over this tab. There we go. Figured out how to take one of these apart from an earlier one. Had two of them that came with a kit. Set that note down right here. I do like how they went to a single piece design for the body, unlike the previous gen where it was a two-piece with the 3 tabs that always broke when you tried to take them apart. Makes it faster, easier, cheaper. And first time I took one apart, I was trying to figure out how to take this cell out. It's in there very tight. And of course, just found out it's very simple. That's it. Let's give it a good whack and it'll pop right out. Okay, now let's take a look at what we got here. This is the thermistor that's used in the overheating circuit. Covered quite well. This is the only part down here that actually does read, and it's actually up against the cell itself because it's measuring surface temperature. And it's a Samsung 20R, since this is out of a 2.0 pack. So I actually do like Samsung pretty well. And now on for the circuit board. Not much to it, as you can tell. It's also a little hard to see. But I will explain where this is, why it's where it's at, why the board is like it's at, on this picture here. This is a picture I took from the previous pack I took apart. So you can see what I got going on. Of course, this is the positive, this is the negative. Well, it says right there, and it probably also says on the tool itself. But the important parts here is not only these two, but here's your thermistor connection right here, which comes to the temperature terminal right here that a majority of high drain tools use. Have yet to see any lighting or any fans that use this. It's just the high drain tools, the drills, the SDS drills, saws, and whatnot. So anything that'll put this pack under heavy load to really start heating them up. These two terminals right here are connected to certain points on the pack itself, mainly connecting the individual cells. These aren't used in any tool, not a single tool. The only device that uses this is the chargers, because this has no battery management system in the pack itself. The battery management system is all in the charger only. So actually you can actually read the voltages for the individual cells. Between these two terminals is one cell, these two terminals are another cell, and these two terminals are another cell as well. And I'll show you that here real quick, since I'm going to be breaking out the tester. Here we go. Ta-da! And let's get this on ohms. We're going to be testing it. We're going to be connecting this terminal to this terminal. See what the measurement comes out as. 12.4847 kilo ohms. Yeah, that sounds about right. Anywhere from 12 to 18, depending on the temperature of the battery, I believe. Now, on to the testing of the, let's get that on volts. Testing of the individual cells. So, we're still going to be, we're going to lead off with this connection right here, the negative. And we're going to be going to this center pin right here. So, we go here, we go here. The first cell is measuring out at 4.14. And now we're going to be going negative on this, positive on this terminal, which is going to be this one and this one. So positive and negative. This is for cell number 2, 4.13. Still very, very close to the first cell. And now between this terminal and this terminal. .13 as well. So reading individually, this is a very well balanced pack. Very well balanced. If it was off by half a volt, I'd worry. If it's off by only like 1/10 of a volt, yeah, you're pretty close. But what we're going to do now is, now that you've seen how the insides work, which, by the way, with everything on here being surface mounted, since it is a single-sided PCB, there is no chips on the bottom. It is all on the top of here. There is nothing underneath. But the reason why there's these two 1K resistors, not only are they kind of used for the circuit, but they're actually used as a bridge to jump across these tracks, because to get from this terminal to the thermistor and back to ground for the system to read it, it has to pass under these. There is no way to do those. So it's a jumper. That's all they are. Just little bridges. And now that we've got that out of the way, what we're going to do is reassemble it and go over some of the troubleshooting. Okay. Troubleshooting. If your charger or tool says that the pack is bad, you can test the individual voltages like I showed you. If they are all pretty well balanced within the voltage range that they're supposed to be, you may want to check a little bit in on the thermal connector itself. Let me just get this tightened down and I'll show you. Okay, there we go there. Okay. Tool or charger or both say that the pack is bad. Check this terminal. Make sure it's clean. Make sure it's not pressed into the body of the pack itself. If the tool and charger can't not touch it, it cannot read it. If it cannot read it, chances are it'll say, hey, this is a bad pack, throw it away, get a new one. How you can check that also is the way I showed you. Positive on here, negative down in here. If you can get a test lead down into there, check the ohms. Should be anywhere, like I said, anywhere from 12 to like 18,000 ohms, kilo ohms. If that's within range, you can test the individual cells like I showed you. If they are well balanced, chances are it's not the pack. That's when you start looking at the tool and or charger. On the charger, I have seen two different charger styles. One faces one way, one faces the other. But you want to find out which terminal this is on. Check that terminal. Make sure it's clean. If you have to, just bend it just ever so slightly. You really don't need to bend them a lot. It's just enough to where you're making contact. But that is especially true in the tools themselves. The tools need to see this, especially the high drain ones. They need to see this. If this is dirty, or that terminal in the battery, or in the tool is dirty, it's not going to read it. It's not going to read it correctly, which is going to flag the circuitry in the tool. Hey, this is either a bad pack, or this is not a valid battery, and it just won't let the tool use the battery pack, even though the voltages are good, simply because of a dirty terminal. And when you check the inside of the tool, just make sure, like I said, it's clean. You might have to tweak it a little bit. Also check to make sure that the terminal in the tool itself isn't pushed up into the tool. If it is, you're definitely looking at having to have that tool serviced, because it's not going to read anything. And if it was, you were lucky that it was reading it. Because tool manufacturers, especially for the battery packs, granted, that's where they get you, is the batteries, but they also have their reputation on the line. Good quality cells, which in my opinion, Samsung is a pretty good manufacturer of cells, same way with LG. But they also want to make sure that their batteries last a while, they charge quick, they charge good, they have a good long run time, because everything is balanced. Everything is going to run well. So it's their reputation on the line as well. Some people say, oh, they have bad cells, they have bad packs. The only ones that I've really seen that have bad packs, knockoffs. Yep, knockoffs will get you. So I like using originals, and that's what's inside. A little bit of testing and a little bit of troubleshooting. So I hope you were able to learn a little bit about these if you didn't know already. If I missed anything, or if there's other information that you have that I didn't have at the time of this, leave a comment down below. Also, if you have any suggestions for future What's Inside videos, also leave those down below, as well as any other comments you would like to leave. And until then, I'll talk to you later. You have a good one.